Okay, so let's look at section 7.3, angles and polygons. So let's look at what a polygon is. What it is a shape formed by 3 or more sides. So something like a triangle has 3 sides, okay? A quadrilateral has 4. So you know, a pentagon, hexagon, so these are what polygons are. Okay, so to figure out the sum of the interior angles, so the angles inside the polygon, we know with something that has 3 sides, it's 180 degrees. Something with 4 sides, 360 degrees. But what about something like a pentagon with 5 sides? What would its interior angles be? So we use this formula here, okay? And what you do is take 180 degrees, and you times it by n, subtract 2. N is the number of sides, and S is the sum, which means all the interior angles if we added them together, okay? So let's look, for instance, at a triangle. We already know that that's 180 degrees. But how many sides does a triangle have? It has 1, 2, 3. So if I use this formula, I take the number of sides, which is 3, I take away 2, I use BEDMAS, 3 take away 2, which is 1, times that by 180, so the sum is 180 degrees. So that's how you use the formula. And pretty much what it means is how many triangles can you make in the polygon. So here I can make one triangle with a quadrilateral. From one vertex I can make 2 triangles, that's why it's 360. If I have a pentagon, here is a vertex. How many triangles can I make from this single vertex? I can make 1, 2, 3 of them. Okay, so I would expect that a pentagon, because there's 3 triangles, 180 times 3 is 540. So if I use that formula, I count the number of sides, 5, take away 2, which is 3. What is this 3? That's the number of triangles I can make. So that is 540 degrees. And that's how the formula works. So let's look at some examples. But before we do that, the one thing we have to remember is the sum of all exterior angles in every polygon is 360 degrees. Whether or not that's a triangle, quadrilateral, pentagon, hexagon, doesn't matter. Okay? Another thing we have to remember is what a regular polygon is. Regular polygons have equal side lengths and all the interior angles are the same. So something like a regular polygon with a triangle, all these are the same. This is called equilateral, right? Something that's 4-sided, this is called a square. But they're regular polygons because all side lengths are the same and all angles will also be the same. So these will all be the same also. Okay, so let's look at the first example. Move it down a bit. Okay, so find the sum of the interior angles of a polygon with 11 sides. Okay, so I'm not going to try and draw it. I'm just going to use my formula. I want the sum, right? The number of sides is 11. Put 11 in for n. Use BEDMAS. So that's 9. 180, multiply that by 9, we get 1,620 degrees. So if I were to add up all the sides in that, all the angles in the 11-sided figure, that's the total of the interior, so inside angles. Okay, let's look at the next one. Find the measure of the each, now this is each, just one of them, interior angles of a regular octagon. Now, octagon has how many sides? It has 8. Okay, so I need to first find the sum. So I take 180, the number of sides is 8 minus 2, which is 6. Multiply that, 180 times 6 is 1,080. Okay, so that's for all 8 sides. Now it just says each. What's one of them? And it's regular. So if it's regular, let's move it up, I know that they are equal, the angles. Okay, So let's think about how am I going to find what one added angle equals. If I know all 8 of them are the same, and it multiplies, so when I add all the angles up and I get 1080. So what am I going to do? I'm going to divide by the number of sides. So I know each angle then is 135 degrees. Therefore, each angle is 135 degrees. Okay. What about each exterior angle? Well, what do I know all the angles of every polygon, all the exterior angles add to? Adds to 360, regardless of the shape of the polygon. So I know an octagon, all the angles exterior add to 360. So I take 360. If I want to know what each is, then I divide it by the number of sides. So 360, I divide that by 8, and I get 45 degrees. Okay? Therefore, each exterior angle is 45 degrees. Okay, last one. How many sides does a polygon have if the sum of the interior angle is 1,440? Okay, so let's think about sum of interior angles. What formula do we have? We have S equals 180 n minus 2. Now, what is this question asking us to find this time? It's asking us to find the number of sides. So are we looking for S or are we looking for n? We're looking for n. N is unknown. Does it tell us what S is? The sum of the interior angles is? Yeah, 1,440. That's what I put in for S. Now I'm going to solve for n. This should look familiar because we did this in chapter 4 when we solved equations. So remember, when you have a bracket, make sure you multiply in first. So 1,440 equals 180 times n, 180n, 180 times -2, -360. Now let's solve for n. So we want this term by itself, so let's move this over. Remember, when you move things over, change the sign, right? And when I add those together, I get 1,800. This equals 180n. Okay, if we want n by itself, remember you got to divide by the number in front of n, which is 180. Oops, divided by 180. Okay, that's a 0. And when you do that, how many sides does it have? It should have 10. Therefore, the polygon has 10 sides. And if you wanted to check it, you could put 10 in here, subtract 2, get 8. Times it by 180, you should get 1,440. And that's it.